All right, so here we go. Everybody ready for problem number 7? Let's look at it and see what's going on. Maddie's going to make 20 pounds of candy mixture. Mixture. Amount times percent plus amount times percent equals amount times percent. That's the first thing that pops into my head every single time somebody says something about a mixture. Okay? Now, let's put some stuff in. Oh, wait. This one doesn't have percentages. What does this one have instead? Instead of percentages, it has prices. So we want to end up with 20 pounds of 360. The things I'm mixing together have prices of $2.50 and $4. Is everybody kind of seeing how this jives with the percentages that we had in our other problems? Now, the only amount they told me is that I ultimately have to end up with 20 pounds. I do not have a clue what these are, so I'm going to call this X. What would this one be then if I have to end up with 20? 20 minus X. Very, very good. If you have to end up with 20 and this is X, then this is 20 minus X. It's whatever's left. So if this were 6, this would be 14 because they have to add up to 20. All right, so now I'm allowed to use my calculator, so by golly, I'm going to use it. I have 250x plus 80 minus 4x. Well, maybe I'm not going to end up needing it. Equals, I think that's 72, but I'll double check. Yep. So I didn't really need it, I guess. So negative 150x equals negative 8, right? Collect like terms and move things around. So x equals 5 1/3, basically. 5.33333, is that what you got? Now let's answer the question. Maybe that's the answer. It says, how many pounds of each kind of candy does she need? Well, she needs 5 1/3 pounds of the 250 kind, right? Because that was X. How will I figure out how much she needs of the other kind? Subtract from 20. So 20 minus X would be 14 2/3 pounds of the $4 mix. Everybody good with that? Now number 8. I don't remember if we talked about these the other day or not. Number 8, you did these in first year algebra. You've got a couple of people, you got a job to be done, and you got a couple of people doing it together. We know John can do this task in 3 hours, but if Mary helps them, they can get it done in 2 hours. How long does it take Mary to do it alone? Now, just like I have a little trick for the mixture problems, or a little kind of formula, I have one for these kinds of problems too. 1 over your time alone plus 1 over the time alone equals 1 over the time together. If you happen to have 3 people on the job, it's the same thing. It would be 1 over alone, 1 over alone, 1 over alone equals 1 over together. So in the problem, John's time alone is 3 hours, so we're going to start with 1 over 3. That's John alone. If Mary helps him, they can get it done together in 2 hours. So that's 1 over 2. Everybody with me? How long does it take Mary alone? So wouldn't that be 1 over x? If x is the number of hours it takes her to do it alone? So now, I don't care how you solve this, you know what I'm gonna do. I'm gonna multiply everything by 6x so that I don't have to worry about the fractions. And of all the numbers in the world, why did I pick 6x? Because that's the common denominator. That's the common denominator. So this will cancel and leave me with 2x. This will cancel and leave me with just 6. And this will cancel and leave me with 3x. Now again, you solve this however it makes sense to you. It makes sense to me to clear the fractions. That's what I want to do. So x equals 6 hours. It takes Mary 6 hours to do the job by herself. Alec, you okay? You're looking at it kind of confused. You okay with that? You sure?
Yeah.
Now, just because we haven't done a lot of that, would you turn over to review number 2 real quick, which is on page 8. And problem 6, or problem C, not 6, 5C. Problem 5C is exactly the same situation. So let's go ahead and do that one real quick. You have to do both of these sheets anyway, so we're going to do 5C real quick. So you do the assignment in 6.5 hours. If Sean helps, they can get it done in 4. How long would it take Sean alone? All right. So what will our setup look like for this problem? One over 6.5 plus 1 over x equals 1 over 4. You okay with that? All right, so now I'm going to multiply through by something that will cancel my denominators, and I believe that'd be 26x. So I'm going to multiply by 26x. How did I get 26? I multiplied 6.5 and 4. So this is going to cancel and leave me with 4x. This is just going to give me 26. And that's going to leave me with 6.5x. So 26 equals 2.5x, and x equals 10.4 hours. So it takes the other kid 10.4 hours. Okay, you think you got the hang of that?
Yes.
Those problems?
Yes.
All right, let's go back to worksheet page 7. And let's see if we can get this done here. Page 7. We're not going to lunch till we make a little bit more progress. So let's get it done. Here we go. The total amount of sales of this in the CHF cafeteria in the past few years is given by this equation. If x equals 0 is the year 1990, x equals 1 is the year 1991, and so on. Find the amount of sales in 2011. This is such a simple problem. What do I need to do if I want the number of sales in 2011? Plug in 11 for x.
Oh wait, no, you have to count. So you plug it in.
Plug in 21 for x, because year 11, I'm starting with 1990. If I was starting with 2000, that would be okay. So I'm going to plug in 21 for x. So the answer is just whatever that equals. You're going to type that in on your calculator, and it's going to give you an answer. And that's all there is to it. Do not make it harder than it is. That is simple. They gave you an equation, you're plugging in an x value. Number 10. Pat sells soccer socks. Okay. He needs to sell his soccer socks for $5.75 a pair, and it costs him $4.16 to produce each pair. His weekly overhead is $38.50. How many pairs of socks must he sell to pay his cathedral tuition of $10,800? So that means we want his profit to be $10,800. Would you agree with that? So we want the profit to be 10.8. Now, how do you find profit? You're in business. How do you calculate your profit?
Income.
Your income or revenue, whatever word you want to use, your income or revenue minus your expenses, right, or your costs. All right, so how much income does he have? What's his revenue? How much is he bringing in?
4.16.
No, 4.16 has nothing to do with the revenue. What's the revenue? What's his income? How much money is he bringing into his store? 575x. X is the number of socks he's selling, or pairs of socks he's selling. Every pair of socks, he brings in that much money, right? That's his income. Now, what are his expenses?
416 plus 3,000.
416x. That's how much it costs him to make each sock.
Plus 3,000.
Plus the overhead he's got, which is $38.50. So here's his total income. The only way he gets income is to sell the socks, and every sock he sells is $5.75. Here's his expenses. We've got the cost to make the socks plus the cost to keep the factory open. And there's our equation. So that's manageable. So 159x minus 3850 equals 1080 or 10,800. Oh my gosh, I got a huge number, did you? I have been having to make 9,214 pairs of socks. Anybody match that?
Yep. Keep a few cents afterwards.
If you're subtracting 38.50 on the other side, wouldn't you have to add it to the 10.8?
I did. And then divided by 1.59. Yeah, I added it. You got 14,650.
Yeah.
And then divided by 1.59. All right, we're going to finish these last two before we go to lunch. So just be calm, be patient, quit watching the clock. All right, Sam is going to box up all these socks. Her box must have a volume of no more than 100 cubic centimeters. Squares are to be cut out. Okay, so you know how we're making the box. We're making the box the same way we've always made the box. We got our piece of paper. We're cutting out the corners. And we're making a box that has a volume no more than 100. Okay, now wait, no more than. Does that mean less than or equal to? Okay, so that's where I'm going. And okay, so the volume has to be less than or equal to 100. How do I express the volume of this box? length, width, and height. And the original paper was how big? 11 by 16. Remember how to do this? How do you express the volume of that box? What's the length?
11 minus 2.
11 minus 2x. What's the width? 16 minus 2x. What's the height? X. And we need that to be less than or equal to 100. Now, when we did these before, we didn't have this 100 over here. We were looking for the maximum. Remember that? Now, we're going to do basically the same thing, at least in the beginning here. We're going to graph it. So I'm going to go ahead and type in actually 2 equations. I'm going to type this in, and then I'm going to type a second equation that's 100. So go ahead and do that. So 11 minus 2x, 16 minus 2x, and x. And then that's equation 1. And then for equation 2, type in 100. Now I'm going to set up my window. Okay? X is domain. Look at the problem. Tell me about X. X is bigger than something and less than something. What are those boundaries for X?
5.5.
0 and 5.5. So I'm setting up my window, and that's it. You can't be outside of those boundaries. You can't cut a negative piece, and you can't cut more than 5.5. Now, can your volume be negative? No. So Y min is 0. I don't know what Y max is, but I know my volume has to be at least, or no more than 100. So I'm going to go ahead and just set it at maybe 120. And now I'm going to make those changes, and then I'm going to hit graph, and let's talk about what we see. Now, hopefully, what you see, if you've done what I told you to do, you will see this. You will see up, down. You see that. Now, what you don't see is the top of the hill. And before, that was really, really important to us because we were looking for the maximum. We don't care. If you want to go ahead and make it bigger so you can see the top of the hill, that's fine. But it has nothing to do with this problem. This problem says, here's where the volume is exactly 100, right? Here's another place where it's exactly 100. Tell me about all of this. That's where it's more than 100? Do I want it to be more than 100? No. What's this? Where it's less than 100? And that's what I want, right? Now I need to find these two x values, and then I'll have my answer. So to find those x values, I'll second calc. And what will I choose if I'm looking for that point right there? Intersect. And I'll set my left bound. So it's over there somewhere to the left. There it comes finally. And somewhere to the right. And that point for me is 1.2, I'll just say 1.23, comma 100, of course. Oh, no, it's not. No, it's not.
Yeah, 0.71.
Yeah, you're right. I didn't press the button. It's 0.72, 100.
Yeah.
And then I start all over again, so second calc again, and now I'm going over to the other side. Just gotta move my cursor over to the other side.
You know how to do this thing?
And for that one, I got 3.94. See if that's what you get. Or did I make a mistake again?
3.94.
3.94?
Yeah.
So now I need to answer the question. The question is, what X values are going to give me a volume less than 100? We agreed it was this part of the curve, right? And this part of the curve, less than 100. So what X values are those? We start at 0. Don't include it. It's not included. We go from 0 to 0.72. And we can include that one because it says no more than, which is or equal to. Right? Why don't I include 0? I can't make a box if it's 0. Right? Doesn't make any sense. Or 3.94 to what? What's my endpoint over here? No, it's not 0. The y value is 0, but what's the x value? 5.5. Do I include 5.5? No, because if you include 5.5, again, you don't have a box. It's disappeared. And the last one, this is a calculator problem. So don't stress about it. If I were you, I would just multiply everything by x. That's easy. Makes sense. Get rid of the fraction. Get it set equal to 0. It's not a quadratic equation. Do not try the quadratic formula. Put it into your calculator and graph it. Now, you have a very funky window set up from the last problem, so I'd go back to just a standard window. And when you graph it in a standard window, what will you be looking for? If you're solving this equation, what will you be looking for? Where it crosses the x-axis. So we're going to go back into second calc again, but this time we'll choose which option? 0. We'll do the whole left bound, right bound thing. And I got negative 2.80. Now, this problem actually could have 3 answers, couldn't it? Because it's an x cubed.
Yeah.
But, turns out, it only crosses the x-axis once. Did you see it? It crossed, and then it did something like this. So it could have come down farther, but it didn't. So we only have the one answer.
Does that mean they're imaginary?
That means the other 2 roots are imaginary. Yes, indeed. All right. Done with the calculator part. Awesome. Now, let me check my time and see when I need you back. I need you back at 12:32. In your seats at 12:32. Quentin, would you turn us off up there, please?
Yeah.
12:32. Everybody's back. In your seat.
I broke my desk.